the module you're most afraid to touch. A parser, a validator, the one client nobody wants to own. Years of bug fixes, edge cases from late-night incidents, behaviors that never made it into the documentation. What if you could delete it anytime and confidently bring it back, working as before? One command turned your code into a compact specification. Another generates the tests, including the weird ones. Delete it. Now, bring it back. Regenerate. It's new code, but with the same behavior as the original. Why did it work? Because you moved what mattered out of the code itself into the prompt and tests. Let's unpack this. In prompt-driven development, or PDD for short, we separate the specification from the code. Prompts are complete mini specifications, one prompt per code file, and tests are the guardrails that protect the shape of the behavior you want. When you have those, the code itself becomes replaceable at any time. And there are additional benefits. First, let's look at what happens to your context with PDD compared to vibe coding. A PDD prompt is about 5 times smaller than the code it governs. Here's a 20-module project, 4,000 lines of code. Compare that to 800 lines of PDD-style minispec prompts. Both describe the same system, yet the prompts cost you 1/5 the tokens. Natural language specifications are just more compact than the implementation. A prompt captures intent, and intent is smaller than the code that satisfies it. So that's the first benefit, more room in context. Here's the second. Natural language is the native language of an LLM. It's what these models were built to understand. They aren't code engines first. So when your inputs are natural language instead of code, you're handing the model the representation it performs best on. Put those together, and you get what we call prompt space, the layer where you work in prompts and tests instead of in code. Prompt space gives you both benefits at once. More of your system in context, in the model's strongest representation. 5 times more of your system, in the model's best language. But why care about context length when models already hold 1 million tokens today? Spend real time with long context, and you'll see it. Performance degrades as context grows. The models get dumber. Chroma documented this in their 2025 research, and they're not alone. So, until future LLMs can truly perform with long context, we should all care about what we put in it. Let's be clear about what's actually different here. When you vibe code, the model ends up with a soup of inputs: open files, your chat history, scratch memory, and the patch you just asked for. All mashed together, and it has to figure out on the fly what matters and what doesn't. A PDD prompt works the opposite way. One prompt for one code file sent to the model in isolation, with nothing else competing for its attention. That discipline is what makes everything else possible. The compactness, the regeneratability, the fact that you can delete the code and bring it back. One prompt is the complete spec for one file, and the model knows exactly what it's being asked to produce. Step back for a moment, because what's happening here isn't actually new. Programming has always moved upward like this. Assembly used to be what humans wrote, until C came along, and assembly became what the compiler produced. Then Python did the same thing to C. Each generation puts a new source layer on top, and what used to be the source becomes the output of something higher. These lower layers never disappeared. We just stopped maintaining them by hand. PDD is the next step up that ladder, and to be clear, this isn't a step from code to vibes. It's a step from implementation text to executable specification. What you maintain in your repo are prompts and tests. the prompt capturing things like contracts, user stories, and example usage. The code underneath becomes the output. Now, you might be wondering, the regenerated code came back different from the original. Is that actually safe? Here's the trick. When generation is cheap, you don't have to trust a single sample. You produce several variants and gate all of them against the same tests, spending cheap compute in place of your scarce attention. You might also be thinking, this is just TDD with extra steps. It isn't quite. In TDD, tests guide a human who's writing the code. In PDD, tests constrain code that no human wrote, and the prompt that produced it stays durable across every future regeneration. And one thing PDD does not do is replace architecture, performance budgets, or security review. It earns its keep at the level of one bounded module, not the system as a whole. And honestly, the real test of whether it works for you is in your own codebase, not in this video. Now, let's talk about what happens if you don't make this shift. If you keep patching code directly with AI coding tools from Cursor, Anthropic, or GitHub Copilot, each individual fix is cheaper. That part is real. But chat is a great interface and a terrible source file. Every patch leaves a trace behind. A new branch, a special case, a duplicated helper, a comment that only made sense inside the conversation where it was written. As the codebase grows up around those traces, the model ends up seeing a smaller and smaller fraction of what actually matters. And the cheaper patches get, the faster they pile up. And the research is starting to catch up with this. In an early 2025 trial, Meta found that experienced developers expected an AI speedup on real work and actually measured a slowdown. And at the delivery level, Dora found a parallel trade-off: more throughput, but more instability along with it. The pattern is simple. AI made each patch cheap. It didn't make the pile of patches cheap. PDD inverts that loop. Each successful generation can feed back as grounding, so the next prompt retrieves it as an example, instead of the model rediscovering the same ground. Patching gets harder as the codebase grows. PDD gets easier. One last way to think about all this. When you make something with a mold, the part that comes out is what you ship. Useful, ready to use, but it isn't the artifact you protect. The mold is. PDD works the same way. The generated code is what you ship. The spec layer above it, your prompts and tests, is what you maintain. And the code can be regenerated anytime, as long as the mold stays intact. That's the part that's actually new here. Not the AI, not even the prompts on their own. It's that there are now 2 layers, and you only have to be precious about one of them. And now you can see, the PDD workflow is what makes AI coding reliable and repeatable. With PDD, natural language can be your new source. So here's a simple rule for when to use which approach. When your system is genuinely short-lived and the fixes are one-off, just use your favorite vibe coder. That's still the right move. But when the system and its behavior need to survive into the future, move to the prompt-driven workflow, prompts and tests. Because patches pile up on long-lived code, and your AI tools see less and less of what they actually need to do good work. So remember, with prompt-driven development, like an injection mold, each code file is recreated whole, conforming to the prompts and tests. Reliable, repeatable code in natural language. That's PDD.